welcome to today's lecture. So, in our last lecture, we had started with unit number 4, that is fluid dynamics. Okay, so we had already seen the syllabus, or we had discussed the syllabus. So, this unit will again have three subsections. Okay, so we had started with the first subsection that deals with the Euler's equation of motion as well as Bernoulli's theorem. Okay, so first of all, we had seen the different types of forces acting on the moving mass of fluid. Okay, so the different types of forces acting are the gravity force, the pressure force. Gravity force is due to weight of the fluid. Okay, the pressure force is due to the difference of pressure from a point at a higher pressure to a point at a lower pressure. Okay, you know, the electric current flows due to difference of voltage. Okay, or voltage difference, and current flows from a point at a higher electric potential to a point at a lower electric potential. Similarly, is the case with fluid flow. Okay, so for fluid to flow, basically difference of pressure is required, and fluid always flow from a point at a higher pressure to a point at a lower pressure. Okay, then next is force due to viscosity. Okay, so you can say this viscosity is also similar to resistance in uh, electric current. Okay, electric current जब flow होता है तो जो flow of electron को resist करता है, that is resistance of the material. Similarly, whenever the fluid is flowing, so there is some opposing force or resisting force to this motion. So that is nothing but viscosity, and more the viscosity, more is the resisting force. Okay, the next is turbulent force. We had discussed the turbulent force is due to turbulent motion, and last one is compressibility. So this compressibility force, okay, it plays an important role in gaseous fluid. Okay, and in case of liquid, it does not play a major role. After that, we had applied this to Newton's second law. Okay, so sum of all these forces equals to mass into acceleration. After that, we had seen for incompressible fluid, Fc is negligible. Therefore, the remaining four forces gives mass into acceleration. So this equation is nothing but Bernoulli equation. Again, if the flow is laminar flow, okay, so in that case, turbulent force Ft is negligible. Therefore, Fx equals to Fgx plus Fpx plus Fvx equals to mass into acceleration. Okay, so this equation gives Navier-Stokes equation. Okay, after that, if the fluid is assumed to be ideal fluid, so then Fv is 0. Okay, so we will have summation of forces is nothing but gravity force plus pressure force. So that equals to mass into acceleration. So it will give us Euler's equation of motion. After that, we had seen the derivation for Euler's equation of motion. Okay, so Euler's equation of motion is dp by rho plus g dz plus v dv equals to 0. Okay, and if you do the integration of Euler's equation of motion, you will get the Bernoulli's equation. Okay, so Bernoulli's equation is integration of dp by rho plus integration of g dz plus integration of v dv. Okay, that equals to integration of 0. So integration of 0 is constant. Okay, so if we assume the fluid as incompressible fluid, so density rho is constant, so we will have p by rho plus g into z plus v square by 2 equals to constant on doing the integration. Okay, after that, divide entire equation by g, so we will have p by rho g plus z plus v square by 2g equals to constant. Okay, so this is nothing but the sum of pressure head plus datum head plus velocity head. This equals to constant. So all this we had discussed in our last lecture. Okay. After that, remember this P by rho g or P by specific weight gamma, P by gamma is nothing but pressure energy per unit weight of the fluid. Okay. इसको definition हमने पूरा derivation के साथ define किया था. Okay. So this P by rho g is nothing but pressure energy per unit head, simply called as pressure head. After that, V square by 2g. This V square by 2g is nothing but kinetic energy per unit weight of the fluid. Okay, or it is simply called as kinetic head or velocity head. After that, Z. Okay, so Z is nothing but potential energy mgz divided by weight of the fluid mg. So mg cancels. Okay, so potential energy per unit weight of the fluid. So okay, so it is called as datum head. After that, we had seen the statement for Bernoulli's theorem. So remember, in a steady flow of an ideal incompressible fluid, okay, in a steady flow of an ideal incompressible fluid, the total energy head always remains constant. Okay, this total energy head is nothing but it is a sum of pressure head plus velocity head plus datum head. Okay, so this pressure head plus velocity head plus datum head, that is total energy head is constant. Okay, after that the assumptions made during deriving the Bernoulli's theorem. So remember, this can be asked in exam. Okay, so the first assumption is the fluid is ideal fluid. Okay, हमने FV zero assume किया था, viscosity zero. So remember, fluid is ideal fluid. After that, flow is steady flow. हमने derivation में assumption किया था कि flow is steady flow. Okay, then flow is incompressible flow. Okay, यहाँ पे हमने assume किया है density को constant करने के लिए flow is incompressible. Okay, and remember this fourth derivation, fourth assumption, that is the flow is irrotational flow. Okay, so all this we had seen in our last lecture. Okay, after that we had also seen the Navier-Stokes equation. Remember the importance of Navier-Stokes equation, all the actual real life flow. Okay, this Navier-Stokes equation does not make the assumption that the fluid is ideal fluid. Okay, it makes the assumption that the fluid is real fluid. So for real fluid, viscosity will be there. Okay, and if you consider the viscosity, okay, so the Euler's equation will be modified to this equation. So this equation is nothing but Navier-Stokes equation. Remember, Navier-Stokes equation आज तक कभी एग्जाम में पूछा नहीं है और आगे भी नहीं पूछा जाएगा. आप चाहे तो ये डेरिवेशन तो आपको सिलेबस में ही नहीं, आप इक्वेशन याद रख सकते हो या नहीं भी याद रखा तो एग्जाम में नहीं पूछा जाता है. बस आपको इतना इंपॉर्टेंस याद रखना है कि Navier-Stokes equation it is applicable to all real fluid flow problems. Okay, और आपके जितने भी सिमुलेशंस होते हैं, जो आपके वेदर के सिमुलेशंस होते हैं, वेदर फोरकास्टिंग होती है, ओके, या फिर जो भी फ्लूइड फ्लो के प्रॉब्लम होते हैं, फ्लो ऑफ फ्लूइड ओवर कार, एरोडायनेमिक फ्लो ओवर कार, ओके, जितने भी सिमुलेशन किए जाते हैं सीएफडी में, all are working on Navier-Stokes equation. Okay, so Navier-Stokes equation gives the solutions to real life problems. Okay, so this much we have seen in our last lecture. So today we are going to see the problems on the Bernoulli's theorem. So write down first problem. Water is flowing through a pipe of 5 centimeter diameter. Water is flowing through a pipe of 5 centimeter diameter under a pressure of 29.43 Newton per centimeter square. Under a pressure of 29.43 Newton per centimeter square gauge. Newton per centimeter square gauge. Okay, gauge means हमें पता है there are two types of pressure, absolute pressure and gauge pressure. So gauge pressure is nothing but it is measured with respect to atmospheric pressure. Okay, so it is 29.43 Newton per centimeter square above atmospheric pressure. Okay, and with a mean velocity of 2 meter per second, and with a mean velocity of 2 meter per second, and with a mean velocity of 2 meter per second, find the total head or total energy per unit weight. Find the total head or simply total energy per unit weight of the water at a cross section which is 5 meter above the datum line. Which is 5 meter above the datum line. Which is 5 meter above the datum line. Okay, so it is a very simple problem. What is given in this problem? There is a section of the pipe. Okay, this is a section of the pipe. Sorry, this is a section of pipe of constant diameter 5 centimeter. Okay, diameter is 5 centimeter. After that, we will take a particular cross section. Consider this is section 1-1. So at the section 1-1, whatever the pressure P, okay, so that pressure P is Newton per centimeter square gauge. Okay, and the water is flowing here. The water is flowing at this section with a velocity of 2 meter per second. Okay, the velocity of 2 meter per second, and from any datum. Okay, from any datum you can consider this is the center line of the pipe. So the center line of the pipe is at a distance of 5 meter from datum. Okay, so this is the datum. So basically this 5 meter is nothing but it is the datum head denoted by Z. Okay, so Z is given, V is given, and P is given, and diameter is given. Okay, we are supposed to solve this problem. So it is a very simple problem, just you are supposed to apply the Bernoulli's theorem. Remember here which fluid is there? Water is there. Okay, so for water, mass density rho, it is 1000 kg per meter cube. Okay, so diameter is 5 centimeters, so 0.5 meter. Okay, it is 0.05. Make one correction. 5 centimeter है divide by 100 होगा 0.05. Okay, pressure is 29.43 Newton per centimeter square. So convert this Newton per centimeter square into Newton per meter square. Remember, 1 centimeter square. 1 centimeter square is 10 to the power minus 4 meter square. Okay, 10 to the power minus 4 मीटर स्क्वायर. ओके, तो यहाँ पे आप 10 पावर माइनस 4 मीटर स्क्वायर डालोगे एंड दिस 10 पावर माइनस 4 it will go in numerator, so it will become 10 power plus 4. Okay, so 1 Newton per centimeter square is 10 power plus 4 Newton per meter square. 1 Newton per centimeter square is 10 power plus 4 Newton per meter square. Remember this. Okay, so pressure is 29.43 into 10 power 4 Newton per meter square. Velocity is 2 meter per second and datum head is 5 meter. Okay, so we know total energy head or total head is nothing but pressure head plus kinetic head plus datum head. So put the values. So pressure head is P by rho G. Okay, so it is P upon pressure is 29.43 upon rho. Rho is 1000 for water and G is 9.81. You can solve this on calci. You will get 30 meter. Okay, so pressure head is 30 meter. After that, kinetic head or velocity head. So kinetic head or velocity head is v square by 2g. Okay, so it is v square. V is 2 meter per second. So 2 into 2 or 2 square divided by 2 into 9.81. Okay, so it comes out to be 0.204. Okay, after that, next is datum head. Datum head is already given 5 meter. Therefore, total energy head or simply total head. Okay, so that is P by rho G plus V square by 2G plus Z. So 30. Okay, pressure head plus velocity head 0.204. Then plus datum head which is 5. So answer is simply add them. So 35.204 meter. Okay, so very simple problem. जस्ट आपको प्रेशर हेड, वेलोसिटी हेड, डेटम हेड तीनों कैलकुलेट करने थे और इन तीनों का एडिशन करना था. ओके, okay, now we will see next problem. Water is flowing through a pipe. Water is flowing through a pipe having diameter 300 mm. Water is flowing through a pipe having diameter 300 mm and 200 mm, having diameter 300 mm and 200 mm at the bottom and upper end of the and upper end respectively. At the bottom and upper end respectively. At the bottom and upper end respectively. The intensity of pressure, at the bottom end, the intensity of the pressure at the bottom end is 24.525 Newton per centimeter square. 24.525 Newton per centimeter square, and the pressure at the upper end, and the pressure at the upper end is 9.81 Newton per centimeter square. Newton per centimeter square. Determine the difference in datum head. Determine the difference in datum head if the rate of flow through the pipe if the rate of flow through the pipe is 40 liters per second. Determine the difference in datum head if the rate of flow through the pipe is 40 liters per second. Is 40 liters per second. Okay, so what is given in this problem? Okay, there is a pipe having diameter 300 mm at bottom. Okay, so it will be pipe like this. Okay, large diameter is at the bottom. Okay, so here d1 is 300 mm, so 300 divided by 1000. Okay, so it is 0.3 meter. Okay, so d1 is 0.3 meter. Similarly, at the upper end, the diameter d2 is 200 mm, so 200 divided by 1000, so it is 0.2 meter. Okay, and water is flowing from top to bottom or bottom to top. Okay, वो हमें नहीं बताया which is the direction of flow. After that, the intensity of pressure at bottom end. That means here we will call this bottom end as section 1 and top end as section 2. Okay, so d1 is 0.3 meter, d2 is 0.2 meter. After that, next is p1. So p1 is 25.525 Newton per centimeter square. Remember, 1 Newton per centimeter square is 10 power 4 Newton per meter square. So it is 24.525 into 10 power 4 Newton per meter square. That is P1. Similarly, at the upper end, P2. Okay, the pressure is P2. So P2 is 9.81 Newton per centimeter square or 9.81 into 10 power 4 Newton per meter square. Okay, this much information is given, as well as whatever the discharge. Okay, the discharge Q through this pipe, it is 40 liters per second. So always remember 1 liter or 1000 liter. Okay, or 1 liter is 1 centimeter cube. Okay, 1 liter is equal to 1 centimeter cube. Okay, so sorry 1 liter is not 1 centimeter cube. Remember 1000 liter equals to 1 meter cube. Okay, 1000 liter equals to 1 meter cube, or 1 liter equals to 10 power minus 3 मीटर क्यूब. ओके, तो यहाँ पे लीटर पर सेकेंड को मीटर क्यूब पर सेकेंड कन्वर्ट करने के लिए हम मल्टीप्लाई करेंगे 10 पावर माइनस 3 और सिंपली डिवाइड करेंगे बाय 1000. ओके, दिस इज द गिवन प्रॉब्लम. So given diameter d1 is 300 mm, 0.3 meter, and p1 is 25.525 Newton per centimeter square. So 25.525 into 10 power 4 Newton per meter square. Similarly, at section 2, d2 is 200 mm, so 0.2 meter, and p2 is 9.81 into 10 Newton per centimeter square. So 9.81 into 10 power 4 Newton per meter square, and discharge is 40 liters per second. Therefore, it is 40 by 1000, 0.04 meter cube per second. Okay, so this is our given problem. Okay, now we will apply the Bernoulli's theorem between section 1 and section 2. Now we know by Bernoulli's theorem, total energy head, okay, it is constant. Okay, therefore total energy head at section 1, okay, total energy head at section 1, it should be equals to total energy head at section 2. Total energy head at section 2. Okay, now we know total energy head is sum of datum head Z1 plus pressure head P1 by rho G at section 1 plus velocity head V1 square by 2G at section 1. Okay, so this Z1 plus P1 by rho G plus V1 square by 2G, this should be equals to Z2 plus P2 by rho G plus V2 square by 2G. Okay, सो हमें सिर्फ वैल्यूज पुट करनी है. आफ्टर दैट वेलोसिटी इज नॉट गिवन टू अस, ओके, but discharge is given. So we know whatever the water which is flowing, okay, that is 0.04 meter cube. So 0.04 meter cube in 1 second. Whatever this water flowing from section 1, the same water is flowing in the given time. Okay, that means in 1 second, same water 0.04 meter cube is flowing at section 2. Okay, therefore we can say discharge q equals to a1v1, that equals to a2v2. Okay, now a1v1 equals to a2v2, and that equals to 0.04. Now we will equate a1v1 equals to 0.04. Okay, so we can say v1 equals to q by a1. Similarly, v2 equals to q by a2. Okay, so v1 equals to q by a1. So q is 0.04 divided by a1. a1 के लिए diameter दिया है, so pi by 4 d1 square. So put the value 0.04 divided by pi by 4 into 0.3 whole square. So it comes out to be 0.5658 meter per second. Similarly, you can calculate V2. So V2 is nothing but uh, uh, Q by A2. So it is 0.04 divided by pi by 4 d2 square. 0.04 divided by pi by 4 into 0.2 square. So it comes out to be 1.274. Okay. Now make one observation. Okay. At point 1, the diameter is bigger. At point 2, the diameter is smaller. So what is happening in between 1 to 2? Diameter is reducing. Okay, diameter is reducing. So whenever the diameter reduces, okay, you can see pressure क्या हुआ है 24 से 9.81 pressure reduce हुआ है. Okay, so whenever the area reduces, okay, pressure also reduces. Okay, और velocity check करो, velocity v1 0.5 था and velocity v2 कितना है 1.274. Okay, so velocity increases. So whenever the area reduces, pressure reduces, and whenever the area reduces, velocity increases. Okay, ये आप एक्सपेरिमेंट घर पे सिंपल कर सकते हो. आप आपका जो टैप होता है, ओके, नल होता है, उसको ऑन करो, water slowly flow होगा, then with the help of your thumb or finger try to close it. Okay, उसका जो ओपनिंग है जहाँ वाटर फ्लो हो रहा है उसको आप थंब से उसको क्लोज करने का ट्राई करो. सो यू विल ऑब्जर्व जैसे जैसे आप उसका एरिया रिड्यूस करोगे वेलोसिटी ऑफ वाटर, ओके, वाटर जो है वो ज्यादा स्पीड से फ्लो होगा. ओके, व्हाई दिस इज हैपनिंग? बिकॉज वाटर को क्यू कांस्टेंट रखना है. ओके, जब आपने उसको फुल्ली ओपन किया था तब भी एक बकेट भरने के लिए सपोज 2 मिनट लग रहे थे. जब आपने उसको फिंगर से पार्शियली क्लोज किया तब भी आप ऑब्जर्व करोगे कि बेसिकली वो बकेट भरने के लिए इतना ही टाइम लग रहा है. ओके, बट बकेट इतने टाइम में भरने के लिए वाटर क्या करता है, उसका वेलोसिटी इंक्रीज कर देता है. सो व्हेनेवर द एरिया रिड्यूसेस वेलोसिटी इंक्रीजेस, एंड व्हेनेवर द एरिया रिड्यूसेस प्रेशर रिड्यूसेस. ओके, सो रिमेंबर दिस फिजिकल फेनोमेना. ओके, ये आपको लाइफ टाइम ये कंसेप्ट आपको याद रखना है. व्हेनेवर द एरिया रिड्यूसेस, pressure reduces and velocity increases. Okay, so now we know the values of velocity and we know the values of pressure. और डेटा का डिफरेंस हमें पूछा है. So we'll apply the Bernoulli's equation between section 1 and section 2. Okay, so we will have P1 by rho g plus V1 square by 2g plus Z1, that equals to P2 by rho g plus V2 square by 2g plus Z2. Okay, तो हम यहाँ पे वैल्यूज पुट कर देंगे. सो P1 का वैल्यू कितना था 24.525 into 10 power 4 divided by 1000 into 9.81 value of rho and g. Okay, into velocity. Velocity is 0.566 whole square divided by 2 into 9.81 plus Z1. Z1 पता नहीं है. So that equals to P2. P2 is 9.81 into 10 power 4 divided by 1000 into 9.81 plus V2 square. V2 square is nothing but 1.274 whole square upon 2 into 9.81 plus Z2. Okay, कैल्सी पे एक साथ इतना बड़ा इक्वेशन सॉल्व करने मत जाओ, बिकॉज कैल्सी पे क्या होता है, इतने ज्यादा एक आधी ब्रैकेट रह गया. ओके, सो वो मल्टीप्लिकेशन की जगह एडिशन कर देता है, ज्यादा कंफ्यूजन होता है. ओके, सो इट इज ऑलवेज माय टिप, आपको इतना बड़ा इक्वेशन सॉल्व करना है तो थोड़ा टाइम जाएगा तो चलेगा, बट आपका आंसर रॉन्ग नहीं होना चाहिए, बिकॉज क्या होता है पेपर चेकिंग के टाइम आपका डायरेक्ट आंसर देखा जाता है। ओके, आंसर रॉन्ग रहा तो डायरेक्ट कुछ कुछ चेकर डायरेक्ट 0 मार्क्स कर देते हैं, ऊपर सिर्फ एक ब्रैकेट नहीं डालने के कारण कैलकुलेशन में मिस्टेक होती है, बट डायरेक्ट 0 मार्क्स हो जाते हैं। ओके, सो सिंपली इतना इक्वेशन सॉल्व करो, इतना इक्वेशन इतने इतने वैल्यू सॉल्व करो, तो फर्स्ट सॉल्व करने के ऊपर सिंपली 25 आता है, ये इक्वेशन सॉल्व करने के ऊपर 0.22 आता है, दैट इक्वल्स प्लस z1 दैट इक्वल्स टू सॉल्व दिस मच, so 9.9.81 cancel, 1000 cancel with 10 power 4, so simply 10 plus solve this, so simply 1.623 plus z2। अब आप कैलसी पे एक साथ सॉल्व करोगे तो आपके चांसेस कम है मिस्टेक होने के। ओके, सो डू वन थिंग, z2 को राइट साइड में ट्रांसफर करो, तो इट विल बिकम z2 माइनस z1। ओके, और लेफ्ट साइड में 25.32 माइनस 11.623। ओके, z2 minus z1, do this difference, so it comes out to be 13.7 meters। है तो हम कौन सा इक्वेशन यूज करेंगे, मॉडिफाइड बर्नौलीज इक्वेशन। और ये आपको कहाँ ऐड करना है, अभी यहाँ पे फ्लो का डायरेक्शन इंपॉर्टेंट है, फ्लो टेक प्लेस इन डाउनवर्ड डायरेक्शन, सो फ्लो इज फ्लोइंग फ्रॉम 1 to 2, तो आपको 2 में ऐड करना है। कभी फ्लो अपवर्ड रहता था तो हम 1 में ऐड कर देते हैं, यहाँ पे फ्लो डाउनवर्ड है तो हम 2 में ऐड करेंगे। आउटलेट पे आपको ऐड करना है। ओके, so remember, as per the modified Bernoulli's theorem, total energy at 1 equals to total energy at 2 plus loss of head. Okay, so P1 by rho g plus V1 square by 2g plus Z1 equals to P2 by rho g plus V2 square by 2g plus Z2 plus HL. Now we will put the values. Okay, now remember, Z1, okay, ये प्रॉब्लम में उन्होंने Z2 को मतलब लोअर एंड को